who has a specific question for our review? Benny?
Numero uno.
Number one. All right, let's start with number one. All right, so in number one, we're asked, are the triangles congruent? Okay, so these yes, no questions, first of all, we have to say yes or no. Then if the answer is yes, we say by what theorem? Remember our three theorems for triangle similarity are angle, angle, side, or side, side. Okay, so we give one of those three theorems, and then we write the similarity statement. So in this image, we know vertical angles are congruent. Anytime you have an intersection of two lines, you know that those are going to be congruent to each other by vertical angles. Okay, so those are the only angles I can mark congruent in this picture because there's no parallel markings on DE and ST. So I can't do like the alternate interior angles are congruent like I do when I have parallel markings. Okay, so it's not going to be by angle, that's for sure. But I've got two side lengths marked with measures. So then I check their ratio. Now, when you do this ratio, remember that you would have to go smaller to smaller, longer to longer. But when I look at this, the triangle DUE over here is isosceles because both of these are marked as 16.
Elmer.
So is this an isosceles in SUT? Are these two legs or sides marked congruent? So I don't even have to check the ratio here because this is isosceles and this is not, so they cannot be similar. If they were similar, they would both be isosceles triangle, okay? And it would have to be that these two would be the legs of the isosceles because of that, those sharing or having that vertical angle congruent, okay? So that is not similar. So the answer on this one is simply no. So you don't write a reason, you don't write a similarity statement, that's it, it's just no. What else? Everybody else is 100% confident in the review? No questions?
Wait.
Yes.
So number two or number four, which is no.
Well, let's check. Okay, so in number 4, we again have the vertical angles. Okay, but this one, none of these are marked, like these aren't the same, 5 and 3 or 15 and 25. So I actually do have to check the ratios here. It's not as obvious because one of them isn't labeled as isosceles. So, but what I would check is 3 would have to, since 3 is smaller than 5, 3 would have to correspond to the smaller side of the other triangle, which would be 15. So I'll set up my 3 is to 15 and see if it's the same as 5 is to 25. So you're asking yourself if those are equal, and both of these, if I reduced 3 over 5 or 3 over 15, if I divide both of those by 3, I get 1/5. Okay, if I divide both of these by 5, I get 1/5. So those are equal, aren't they? So I've got two sets of sides that are proportional, and then the angle between those two sides is congruent. So this one is a yes by side, angle, side, and then you have to give the congruence, or excuse me, the similarity statement. So triangle what is similar to triangle what? So you get to name them how you want. Okay, so in the first triangle on the left, so if I do JKH, if that's the order I decide to name it in, I have to put it in corresponding order for the second triangle. Thank you. So J to K is the side that doesn't have any label. And then K to H is the one that I color coded in red. It's the longer of the two labeled side. So the unmarked to the longer. So I have to correspond to that over here. I have to go the unmarked to the longer of the two. So G, H. Now, if you chose to name this triangle on the left differently, that would change the triangle on the right, the order that you put those. You have to make sure that they correspond. So far, so good? What else? 11? All right, so looking at 11, and you can see if we scroll through and some are done, because I did them in another class, you can take a look at it if you want to. I did 8 with the other class. But number 11 says that we find the length, they want us to find the length of MK if the answer is not a whole number, answer in simplified radical form. So this is a geometric mean question. So we have an altitude in a right triangle. So our right triangle, JKL, has this altitude from the right angle drawn, okay, KM. So this is geometric mean. Now what I'm looking for, I'm going to put an X on MK. That's the actual altitude or the height of that triangle. So we have to use the altitude rule of geometric mean. I don't know why it keeps erasing as I'm writing. Seriously? Okay, well, I'm not going to write the word altitude rule apparently. Okay, but the altitude rule says that the altitude squared, so in our case, x squared, is the product of the two pieces of the hypotenuse. Okay, the two pieces that the hypotenuse is broken up into. So in that original triangle, JKL, okay, the hypotenuse is JL. That altitude separates it into two pieces, and we're told that they are 22 and 6. So it's the product of 22 times 6. So I multiply that, and then how would I get rid of the square on the X? Take the square root. So when I take the square root, if it is not a perfect square, I'm going to have to simplify the radical, which this is not. Okay, so we know 121 is 11 squared and 144 is 12 squared. So this is somewhere between 11 and 12. But they don't want a decimal. They want a simplified radical. So we're going to do our factor tree, which you can start with any factors, but I think it makes sense to start with ones you already for sure know, because that's where 132 came from, was 22 times 6. Okay, and then the 6 can break down to 3 times 2. The 22 can break down to 2 times 11, and then those are all prime, aren't they? So then there's a pair of 2's, so a 2 gets to come out, and then there is not a pair for the 11 or the 3, so those both have to stay in the radical. Remember, whatever comes out gets multiplied, whatever stays in gets multiplied. So this simplifies to 2 root 33. And you can confirm that with your scientific calculator. You can type in square root of 132, and then you could type in 2 square root of 33, and you could confirm that you get the same decimal for both of those, which you do. Okay, that it just confirms that you did your simplifying correctly. Okay, so that is the, why are you erasing? It's supposed to be outline. That is the altitude, that's MK, the height of that triangle. Again, we're not going to give you the geometric mean formulas. You have to know altitude rule and leg rule. Is there another one y'all want to go over? Benny, did you have your hand up for another one a second ago?
It's 13.
You want to look at that? You still need help with it? Yes. Okay, 13. I actually did 13 and 16 here with my last class. But what I did they tell you you have a line segment PQ, and they give you the original values of P and Q endpoints, okay? Then they say that they are dilated about the origin, and they give you P prime, so the new coordinates of P, where it ends up after the dilation. So we can use that to figure out the dilation rule. So 2, -7 becomes 6, -14. So we look at those X's I underlined in red and the Y's I underlined in green, and I'm asking myself, what's the scale factor? Because that's what a dilation is, right? It's multiplied by a scale factor. So what did 2 get multiplied by to become 6? 3. So the X is being multiplied by 3. What did the Y get multiplied by for -7 to become -14? 2, right? It was doubled. If you don't see that immediately, just going backward, you just divide. -14 divided by -7 is 2. 6 divided by 2 is 3. Okay, so those are our scale factors for the X and the Y. It's not the same for both. So you have to write 3X and 2Y. That's your rule. Now they give you the original Q and ask for the new Q prime. Okay, so we have the pre-image. We apply our rule. So we multiply -22 times 3 and get -66. And we multiply our Y, 3, by 2. 3 times 2 is 6. So Q prime ends up at -66.6. And you can see for number 16, it was done similarly. I did note with my last class that I don't like that they just said transformation and they didn't tell you it was a dilation, because there's other transformations like translate, reflect, rotate. We haven't reviewed all of those this year. That's actually in our next unit. The only one we talked about in this unit is dilation. So I would for sure make sure on the test that it tells you dilation, not just transformation. Okay. But this point is dilated to become this point. So we have to figure out the rule that was used. Okay. So you could write, and this one happens to be consistent for the X and the Y. Both of them are just cut in half. Okay, so the K, the scale factor is 1/2. You could write it inside with the X and the Y, or you could write it outside here like this. Yeah. 21. All right, and number 21 says, what is the value of X round to the nearest whole number? So we are given these nested triangles, and we're not told that the line cutting through the original big outer triangle is parallel, but we are given these angle markings that tells us they must be parallel. Because if those corresponding angles are congruent, then these lines are parallel. So we learned that when you have a triangle cut by a parallel line to one of the sides, okay, it creates proportional pieces. So that means that the 15x minus 1 is to 14x plus 6, as 35 is to 33. That is not the only way I could set up the proportion. I went top left to bottom left, top right to bottom right. I could have gone top left to top right, bottom left to bottom right. Okay, there's different ways, or you could have completely just flipped both of these and gotten the reciprocals. Okay, so there's like 4 different ways you could set up this proportion and it will work out the same. Okay, but now when I go to cross multiply, this is not a basic one because I've got these expressions. So I have to remember when I'm cross multiplying, that 35 has to be distributed to both the 14x and the 6. That 33 has to be distributed to both the 15x and the minus 1. Now, some of you will distribute like in your head and write the next line. Some of you will prefer to write it out pre-distribution. You may prefer to write 33 and then parentheses 15x minus 1 equals 35 parentheses 14x plus 6. Okay, and that's fine. Some of you don't need to show that line, and that's okay too. Okay, because we're going to distribute both of these. Okay, so the 33 times 15 is 495. And the 35 times 14 is 490. And the 35 times 6 is 210. Oh. So then it's just basic algebra. We're going to get x's to one side, constants to the other. So I'm going to move my 490x. To get rid of it on the left. So 495 minus 490, so I've got 5x minus 33 equals 210. Then I'm going to move the 33 to the other side. So then I've got 243. Then I will divide out the 5. And it did say to round to the nearest whole number. So 243 divided by 5 is 48.6. So what should I round that to? Okay, when you have the equal line but squiggly, that means approximately. So it's approximately 49. That's X. Is that what they asked for? Double, like you go back, it's never hard. It never hurts to go back and reread the question and make sure you've answered what they've asked for. Because sometimes they're asking for a segment length and not just X. So you just want to double check that you're done with the problem. What else? Yeah. 23. All right, so let's take a look at 23 then. So this is another one that asks for the length of a, okay. This, you need to add something. This was hand drawn to add in here, and they didn't give you the information that these are parallel. So just add those parallel markings so that we can accurately solve this. So if we have these marked as parallel, the nested triangle is similar to the outer triangle, and we're looking for AB, which in the nested triangle corresponds to the 50, yes? Okay, now I know both sides, the small side and the long side on both of these. I'm going to use the one that doesn't have a decimal. Okay, so I'm going to go with this side over here. So this is the small side is 71. What would be that entire length over there? What would I do to get that? I'd have to add them. So 85 plus 71 is 156. So if we're going to set up our proportion, I'll call this X. We could do a couple of things. We could say X is to 50. So I'm doing the big one to the small one. So I would do 156 is to 71. All right. Then you cross multiply and divide. So 50 times 156 divided by 71. And this one says also to round to the nearest whole number, because that comes out to 109.86. So what would that be to the nearest whole number? 110. What else? 26. All right, so in 26, we have the triangles that are kind of like the bow tie where that have the intersection of the lines. Now this one does have the parallel markings here. It's kind of hard to see. They've got little arrows on here. If you didn't see that on yours, you can add them. Now, because of those markings, I know that these triangles are similar because alternate interior angles would be congruent. And the vertical angles in the middle would be congruent. So I know these are similar triangles, and they are asking for GK. So that is this total length. So I need to find this partial length from H to K right here. And then once I know that, I can get GK and by adding the 7, right? So I need to look at what corresponds to what to set up my proportion, my ratios. So that's why having the angle markings sometimes helps, because I can see, so X that I'm looking for first is between the red and green angles I marked. So that would correspond over here to the 7, wouldn't it? Between the red and the green over there. So I could say, okay, X is to 7. And then I could do the same thing and look at what corresponds. The 4 here and the 9 here correspond because they're between the blue and the green. Now, which one should go on top, the 4 or the 9? I did X on top. So this left triangle. So I need to be consistent. I needed to do the 9 on top. Does that make sense? Now, if I solve it this way, I'm doing 7 times 9 divided by 4. And so I'm getting that X is 15.75. If you messed up and you set the 4 over 9, you would have ended up doing 7 times 4 divided by 9, which comes out to like 3 point something. That should clue you in that you made a mistake because you're getting a smaller side here. And in this triangle, the yellow is bigger than the blue. So here, the yellow should be bigger than the blue. Does that make sense? So it kind of just logics out, okay, this X should be more than 9 because that 7 is more than 4. So if you set up your proportion wrong, think about just like kind of the logic of it, or I don't want to, it's not necessarily common sense, but if you think about it, X has to be longer. Okay, if you look at how it corresponds over here. So if you set it up the wrong way and got a number less than 9, that should be a hint to you, oh, I did something wrong or I set it up wrong somehow. Okay, so this comes out to 15.75. Now the entire thing, G to K, all the way here, you're going to have to add that 7 in. Bless you. So you got your 15.75 plus 7 is 22.75. And they didn't tell you anything about rounding, so we're going to leave it as 22.75. Feel okay about that one? What else? 24? Yeah, let's do it while we're here. So number 24, what is the value of X round to the nearest? This is another one that they should tell you that these are parallel. So that you know that this nested triangle is similar. Okay. All right. So this one is a little more not necessarily confusing, but you have to think about when you're setting up your proportion. If you do 25 is to 16x minus 5, you're doing the small triangle's base to the big triangle's base, right? So when you go to set what that is equal to, it should be small triangle to big triangle. So over here, if you start with 5, it is not going to just be x plus 6 in the bottom, because x plus 6 is not the length of the large triangle, is it? What would be the length of that large triangle on the left side? X plus 11. So you have to be careful and see that. So we should put x plus 11 here in our proportion. So then, similar to what I did on the other one, when I have expressions, I'm going to have to distribute. So the 5 is going to get distributed to the 16x and the 5. So that comes out to 80x minus 25. And then the 25 has to get distributed to the x plus 11. So you get 25x plus 275. Now I get my variables to one side. So I'm going to move my x's over. So 80 minus 25 leaves me with 55x. I'm going to go ahead and move my 25 over to the other side. So 300. And then I'm going to divide out the 55. So 300 divided by 55 is a decimal again. And this time they do tell us rounding instructions. They say round to the nearest whole number again. So this comes out to 5.45 repeating. So that would round to approximately 5. Okay, that's closer to 5 than 6, right? So that would be the nearest whole number for x. And again, double check. Did they just ask for x or did they ask for one of the side lengths? They just asked for x, so we can stop there. 32. All right, 32 says triangle LMN. In triangle LMN, P is the midpoint of ML. Q is the midpoint of MN. So I'm going to mark that. That means that these are congruent and these are congruent. If these are midpoints, this is a mid-segment, yes? We learned that in the last unit. Okay, and then they tell us that mid-segment PQ is 9. Then they say the triangle is dilated by a scale factor of 2/3. What will be the length of the image of LN? Well, remember, this is the pre-image. This is before the dilation that this is 9. So right now, could you tell me the length of LN in the pre-image? If the mid-segment is 9, what's that side of the triangle it's parallel to? 18. So this is the pre-image. Because the mid-segment is half the length of the side it's parallel to. Again, that we learned about mid-segment last unit. So this is incorporating what we used last unit plus this unit. We learned about dilation. So in the pre-image, before the dilation, LN is 18. They're asking in the new image, after, bless you, after the scale factor. Well, your scale factor is your multiplier. You are multiplying by that scale factor. So I'm going to do 2/3 of 18. Or 2/3 times 18, however you want to think of it. Okay, and you do get a calculator. You don't have to be able to do this by hand, but I think most of you can. Because if I do the 18 over 3, that's just 6 times 2 is 12. So I found LN in the pre-image and then I dilated it. That's one option. Your other option is to take the PQ, dilate that, and then double it to get the LN image. And that would get you the same thing. Because if I dilated 9 by 2/3, that would be 6, wouldn't it? And then I double 6, and that would be 12. So you can either double then scale or scale then double. It doesn't matter. Yeah. 29? Yeah. All right, so this one says a street light cast. Okay, so this is one of like the word problems. I believe I had one on the quiz like this as well. It had a picture there. This one doesn't have a picture, so we're going to draw one. A street light casts a 15-foot shadow from a 10-foot pole, while a nearby building casts a 45-foot shadow. What's the height of the building? What's the ratio of height to shadow? So if they're under the same light, their shadows are going to be proportional. That's what we need to understand. So a street light, and you could do them nested, you could do them, it's probably best to do them nested. Like if you want an actual picture, we've got this building. I'm going to draw it like a skyscraper. Oh my gosh, stop erasing when I'm writing. Okay, this is my little skyscraper. That's a terrible drawing. I get it, whatever. Okay, and it's casting a shadow on the ground. Okay, so a building is 45. Its shadow, oh, sorry, the shadow is 45. Okay, what's the height of the building? That's what we're looking for. Okay, so the building is 40, the building's shadow is 45. How tall is the building? If the street lamp, so the street lamp is 10 foot high. So maybe like here is the street lamp. It's 10 foot. Its shadow is 15 foot. Okay, now this forms these nested triangles like this. Y'all understand how I drew that from the image? Okay, so the building is taller than the street lamp. Okay, the street lamp's shadow, because this is like the light shining at this angle. Okay, or the sun, I should say. So the sun's creating the shadows. So 10 is to 15 as X is to 45, because 45 is that whole length, right? So 10 is to 15 as X is to 45. And then you would cross multiply and divide. So 450 divided by 15, and you get 30. These were all given in feet, so this is 30 feet. Yes. Uh-huh. All right, I actually did 27 in my last class, but let's take a look. This one had an extra step because I labeled in my picture what I was told. Okay, I was told that ED is 9, AD is 12, and CD is 4. Find the length of BE, so I put an X there. Okay, now I know that these are similar triangles because they told me so. I labeled the angles based on how they correspond. You don't have to label the angles like I did, but that's helpful to some of y'all. So I see this small nested triangle inside the larger triangle, BCA. When we have a parallel line creating these nested triangles, okay, and I know that this is parallel because they told me these are similar. These angles are congruent, so that means this must be parallel. But we were told when that happens, when you have a line cut through your triangle parallel to one of the sides, that these sides that are intersected proportionally. So the X, this BE would be to EA as CD is to DA. Or you could do BE is to CD as EA is to DA. But the thing is, we don't know EA either. Okay, we have 2 missing pieces that we need. However, they did tell me ED is 9, and this is a right triangle. This was marked as 90 degrees. So when I have a right triangle and I know 2 of the sides, I can use Pythagorean theorem to find the 3rd side. And in this smaller right triangle here, 9 and 12 are the legs, so that's your A and B. The hypotenuse is what we're looking for. That's your C. So I did Pythagorean theorem, and I found that EA is 15. Now that I know EA, I can set up the proportion. I can say, okay, X is to 4 as 15 is to 12. Or I could have done X is to 15 as 4 is to 12. That would have worked as well. Okay, and I know logically looking at this, since 4 is less than 12, I know X should be less than 15. So when I get my answer, it should make sense. Okay, it's less than 15. Okay, but it's longer than 4 because this portion was longer than 12. Does that make sense? Okay, what else? 5. Okay, so 5, this is another one that I did in my last class. It asks, are the triangles similar? If so, give the theorem and state the similarity statement. So in this one, this was tougher because they only gave 1 angle in each triangle. However, these tick marks mean congruent. Okay, so since both of these are marked congruent within the individual triangles, that's telling me both of these are isosceles. So I can use the fact that they're isosceles and that the 3 angles of a triangle add to 180 to find the missing angles. So if my vertex angle is 46, okay, that leaves me with 154 degrees to split between the base angles. So 134. So 134 divided by 2 is 67. So I knew these base angles had to be 67 degrees in this triangle JOS. In the triangle HEP, they gave me 67 as one of the base angles. So I know the other base angle must be 67 and the vertex must be 46. So I can see, yes, all of these corresponding angles are congruent. So by angle, these triangles are similar. And so then your statement could vary, but they need to be corresponding. The J has to be in the same spot as the E. Okay. And actually this one's a little different. The S and the H are the 46 degree angles. The S and the H definitely have to be in the same spot. But because these other angles are congruent, it's an isosceles, the J and the O technically could switch. You could do J to E or J to P. Okay, so that one was had some more possible correct answers because it's isosceles. All right, this is due tomorrow. Your test is tomorrow. Make sure you finish it up. I'll post the key. I'll post the videos after school. Okay, work on your quiz corrections. That would really be helpful in preparing for the test as well.